let's look at matrix multiplication. That's multiplication between two different matrices. So that's quite different than scalar multiplication, so I don't really want to group those. And it's different than addition and subtraction because when we multiply two matrices, we don't just multiply the corresponding elements. So that's a really common, that's kind of instinctual to just multiply those elements like we do with addition and subtraction and even scalar multiplication. But when we multiply a matrix by a matrix, it's a bit more complicated. And before we can even start, we have to make sure that those A and B are going to be compatible. It's not about being the same order like it is in addition and subtraction, but it's about having the right combination, which is the product of A and B. I'm looking at this study tip now, of A and B to be defined, the number of columns in the first matrix must equal the number of rows in the second. So if I have an A that is m by n and B that is n by p, then I have to check that these two, those inside values are equal. So the columns are equal to the rows. The columns of the first one are equal to the rows of the second one. So if you write it like this, where you have your order, remember that, not remember because I never told you, but matrix multiplication is not cumulative like it is in scalars. Like if I have scalars, 5 times 2 is the same as 2 times 5, or 5 times x is the same as x times 5. But that's not true with matrices. Matrix A times matrix B is not equal to BA. So it's not cumulative. Order matters. I'm going to write that. Order matters. So you can write them in order. Write your matrix and your matrix, and then write the order of each matrix underneath it, and check that those inside values match. And if those inside values match, that means that that multiplication is defined, and the result matrix will be the outside, the M and the P, the rows of A times the columns of B. And the reason that it's kind of complicated like that is because of the way that matrix multiplication is defined. We take, look at this illustration over here. It's kind of explaining that definition. We take a row of a matrix, and each element of that, we multiply the first row, we multiply by the first column. The second row, we multiply by the second column. The third row, we multiply by the third column. And then we add those together to get a single element. So I like to teach this in person by using, I literally use my fingers when I am doing this multiplication. So I don't know how to show that on here without multiple arrows on the screen. I'm just going to draw in some little fingers here. So I put my finger here on A1 and on B1, and then I slide my finger this way while this one's sliding this way, because the sum of these three products is equal to one element. So if I have a matrix A that is a 1 by 3 multiplied by a 3 by 1, then I end up with a matrix that is, okay, so those are compatible because the insides match. The outsides give me the size of the result, the product. So my result is going to be a 1 by 1. So you can see multiplying all these numbers together, I still just get one element. Okay, so here's that official definition. Each element is actually a sum of products. All right, so let's try some addition here. So in your homework, you have 31 through 50. So let's try BF. So first I want to check the dimensions. The dimensions of B, let's see, B is a 1 by 3 matrix, and F is a 3 by 1. Remember, it's R by C, row by column. and I check my inside values, the 3 and the 3 match, well, that means that this product is defined and I can proceed. And then my result is going to be a 1 by 1. So my product BF is going to be a 1 by 1 matrix. So when I look at this one and this one together, I like to put them side by side because, like I said, with the I'm going to basically do this with my fingers, and I like to have my left hand. Actually, I'm going to do this. Let's see. I'll have my left hand pointing to the 2 and my right hand pointing to the 1. And then I'll think in my head, okay, so I'm looking for I only have one element here, so it's going to be a sum of products. So this is first row. This one is going to be first row, first column, but there's only one row and one column. So I just add them together. So I have my product of 2 times 1, which gives me a 2. And then I slide my finger down. I slide my left hand to the right, and I slide my right hand down. And then I get 0 times 0. I add that. And then I continue sliding my finger to the right, my left finger to the right, and my right hand down. And I get -3 times 1, which gives me a -3. So that sum is a -1. So that goes in the first row, first column. Oh, you know what I did? I'm sorry. I covered up my negative with my arrow. That should actually be a, sorry about that. That last one should be a -1 times a -1. So that's a +3. So this is actually, that sum is a 5, not a -1. Sorry about that. So that's how I get BF. Let's see, before we go on to 34, I want to do one more addition practice. Multiplication, sorry. Actually, let's go ahead and do 34. We'll get multiplication at the end of this. So we need to start with, well, first thing I want to do is, remember, multiplication is not always compatible, so I really want to double check that it's going to be compatible before I waste my time even adding A and E. So first, think about my A and E matrix. So A plus E, remember addition, the matrices have to be the same order, and my sum will also be the same order. So those are both 3 by 3s. So this A plus E, that sum, will also be a 3 by 3. And D, let's see, D is a 3 by 2. So I check my inside values, and yep, those are the same. That means this product exists. And my result will be a 3 by 2. That'll be my product. Okay, so start with my parentheses. It's taught as the order of operation, so I do parentheses first. So I'm going to do A plus E first. And then I'll multiply that by D. So what's A plus E? I know it's going to be a 3 by 3. Because A and E are both 3 by 3s. And when I add them, I'll still have a 3 by 3. And then I'll multiply that by D. Excuse me. Make sure your D comes after A plus E, because remember, order matters. So if I put D in front, then that's going to have a different value. So D comes after. Order matters with multiplication of matrices. Okay. So A plus E, I'm just going to look at my corresponding parts for A and E. So here's A and here's E. So my 1 plus a -1, I get 0. 2 plus 0, I get 2. And the -1 plus 1, I get 0. Adding all my corresponding parts. And I get that for my A plus E. I'm going to color code this. So my A plus E, let's do that in this light blue, is this part. And then I want to multiply it by D. So for D, I'm going to go ahead and write the matrix for D here. Whoops, in pen. Which is 3 times 3, 1, 2, 0, negative 1, 5. I really like to have them side by side because then I can do my finger pointing. It does get a little more complicated. With 32, we just had 1 row, 1 column. But now I have 3 rows and 2 columns. So my first row, first column, I take my finger on my first row and move it along the first row on my left hand, and I take my finger on my first column and move it down the first column, and I want the sum of those products. So row 1, all the elements of row 1 with all the elements of column 1. That will end up in, let's see, I'm going to do a matrix down here. So I know my result's going to be a 3 by 2. So I'll go ahead and draw in a 3 by 2. And I'm going to try to get this element right here. So that element right here is row 1, column 1. So I look at row 1 of this matrix and column 1 of this matrix and add up the sum of the products. So that's a 0 times 3 plus 2 times 1 plus 0 times 2. And I get 0 plus 2 plus 0, which gives me a 2. Okay? And then I'm going to repeat that process for the next spot. So I use my finger again, and I'll point. Now, for this spot, this one's going to be still row 1, but this time column 2. So I'm looking at row 1 still again, but this time I'm looking at column 2. So I'm going to erase that old one. And I take my finger and start at the 0 on the row 1 and 0 on the column 2. So 0 times 0 is 0. And then slide my finger to the right. My left hand slides to the right. My right hand slides down. The next number is 2 times negative 1. So adding the sum of the products. So 2 times negative 1. And then 0 times 5. So 0 plus negative 2 plus 0 gives me a negative 2. Okay, now I'm going to erase those colors and use a new one. My next spot will be right here. So that is, let's see, that's still row, no, now it's row 2 now. But now we're looking back at column 1 again. So now we take row 2 and column 1. And I start with my 2 plus 3. Slide my finger down to get the 4 times 1. Did I say plus 2 times 3? I don't know if I said that or not. 2 times 3, 4 times 1, and 5 times 2. And add those together. And I get 6 plus 4 plus 10, so I get 20. Oh, you know what? I think I messed up because I said this matrix is 3 by 2, but I made my boxes too big, so I need to leave 3 numbers there. There we go. So that should be a 20. Okay, so following that same process, I'm just going to keep going. So I'll erase, I'm done with those, so I'll erase these. And then in this spot, we have row 1, column 2. Row 1, row 2, column 2. So that's row 2, column 2, multiplying those together. I get 2 times 0 plus 4 times -1 plus 5 times 5, which gives me 0 plus, minus 4, plus 25, which gives me 21. And then erase those two. And then this guy will be, now this stuff that I'm writing on the outside, that I usually do in my head, unless it's a complicated one, like for example, that one I probably would make a little side note, but I don't have to show my work on each of those. Once your fingers kind of get trained, you get some muscle memory where your left hand will move to the right and your right hand will move down. You'll get some muscle memory if you have those matrices next to each other. So for this one, we have row 3, column 1. That's row 3, column 1, multiplying those two together and moving my finger. So starting at 2 times 3, and then 1 times 1, and then 3 times 2, which gives me 6 plus 1 plus 6, or 13. And that last number, we have run out of space, is what we have done. So that guy is going to be row 3, column 2. So row 3, column 2. Multiplying these two together, I multiply 2 times 0 plus 1 times -1 plus 3 times 5, which is 0 plus -1 plus 15, so 14. Okay, so all these scribbles all around are my thoughts, and I use the colored boxes just to demonstrate where I'm putting the numbers. But really, what would go on my final paper, because your fingers really do get trained, I just write this matrix as a 3 by 2, and then I get 2, -2, 20, 21. I don't get it this fast, of course. I still got to do that multiplication and adding of the products. But there's my final product. All right, so we still have one more to do, number 40. That involves a multiplication of matrices and scalars. So I do the matrix multiplication first. So let's see, E. Remember, scalar multiplication doesn't change the dimensions. I need a new color for this guy. So E is a 3 by 3. And D is a 3 by 2. Those insides match, so that is defined, and my product will be a 3 by 2. Okay, so I'm going to do that, kind of run out of room below, so I'm going to just slide this guy over here and do it over here. So I have a -3 times E D. I do think it's important to actually copy them down because it's so easy to make a mistake and forget which row and which column you're doing. So your finger muscle memory will really help. So having them side by side like this helps you put your finger on the left matrix, that -1, and your right finger on the 3, and know that that's going to be that first row, first column, or the beginning of. So when I fill this in, I'm going to end up with a 3 by 2. So I'll have -3 still, and then I'll have a 3 by 2 as my product. So my row 1, column 1, that's row 1, column 1. When I add those products, I get -3 plus 0 plus 2. I'm doing those products in my head now. -3 plus 0 plus 2 gives me a -1. I'm going to write that a little bit more to the right because this is only 2 wide. And then for the next one, I'm still in row 1, but now I've moved over to whoops, too much. Oops, too much. There we go. Column 2. And I add those products. So I have 0 plus 0 plus 5. So that gives me a 5. And then I have my fingers now on row 2, column 1, and I do 2 times 3, 6, plus 1 times 1, which is 1, plus 4 times 2, which is 8. So that's 6 plus 1 plus 8, which gives me a 7 times 8, which gives me 6 plus 1 plus 8. Oh, 7 plus 8, 15, yes, sorry. Okay, and then, okay, so then my finger comes off of those. Whoops, keep writing too close to that. And then I put my finger on for row 3, column 1. I have -3 times 3, that's a -9, plus 1 times 1, which is 1. So now I have -8, plus a 5 times 2, which is 10. So -8 plus 10 gives me a +2. Okay, then I lift my finger up from that column and row, and I go to the next one, which is, so now I have, let's see, that's row 2, column 2. And adding those products, I have 0, -1, plus 20, which gives me a 19. And my last one, I have, so lift up my finger from those, and now my finger goes in the last row, last column, and I get 0, plus a -1, plus 25, which gives me 24. All right, now I got to take all of these and multiply them by 3. And I get the same size matrix, 3 by 2. Multiply -3 times -1, I get 3. -3 times 15 gives me a -45. -3 times 2 gives me a -6. -3 times 5 gives me a -15. -3 times 19, I'm going to do -3 times 20 to get 60, and then subtract 3. So that gives me 57, -57. And 3 times 24, well, that's hard too. So I'm going to do 3 times 25 to get 75, and then subtract 3. So I get -72. All right, so there's our matrix multiplication. You can see it's quite more complicated than scalar multiplication. But your muscle memory really does get trained, and it goes a lot quicker as your fingers learn what to do.